Clearing fractions, a math skill that's really important to understand is this notion of clearing fractions. What does clearing fractions mean? Let's start by considering the following three-termed equation. 1/3 x, which means 1/3 times x, plus 1/2 is equal to 13/6. Each term has a fraction. So the first term has 1/3, the second term has 1/2, the third term has 13/6. Now, it is possible to rewrite this equation without fractions. But before doing so, it's important to remember one of the basic mathematical principles that applies in this situation. So the big idea is this. If every term in an equation is multiplied by the same value, the equation does not change except for its form. Now, my example here doesn't have fractions in, but just to show what I mean, if we have an equation such as 2x plus 6y is equal to 10, then we multiply each of those three terms by a number, and I just arbitrarily picked 3. We then get 6x plus 18y is equal to 30. If we were to graph 2x plus 6y is equal to 10, and 6x plus 18y is equal to 30, we would see that they are the same line. They're essentially, for all intents and purposes, the same equation, just a little different form. We're going to take this idea with us as we move forward. In order to clear the fractions, it is necessary to multiply each term by the least common denominator, the LCD. In other words, we are looking for a number such that all of the denominators will divide evenly into this number. So in this case, the smallest number that the denominators, so the denominators here are 3, 2, and 6. Smallest number that those numbers will divide evenly into is 6. Therefore, our LCD is 6. Now, how do we get that? Well, you can go to the biggest number, 6. It divides into itself. Do the other numbers there divide into 6? Yes. If they didn't, we would take a multiple of 6 and go, say, to 12 and see, do those numbers divide in? Now, in this case, 12 could also be a common denominator, but it's not the smallest one. It's just an advantage to get the smallest one. So now we're going to take 6 and multiply it by every term, because we know that by multiplying an equation by each term by the same number will give us essentially the same equation. But in our purposes, it will eliminate the fractions. We'll take 6 times 1/3. So 6 is the same as 6/1 times 1/3. And when we multiply fractions, we multiply numerators, 6 times 1. Multiply denominators, 1 times 3. And then 6 divided by 3 is 2. It's the same as 2. Then you take that result and multiply by whatever else is left in the term. In this case, there's an x. So we take 2 times this x. Hence, we have 2x down here. Now, I like to draw these arrows just to indicate and remind myself that I need to multiply this number by every term. So now I go to the second term. So what's 6 times 1/2? 6/1 times 1/2 is equal to 6/2, which is 3. So 6 times 1/2 is 3. That's why we got the 3 right there. And then the last term is 6 times 13/6. 6/1 times 13/6 is 78/6, which is 13. So we've taken this expression, or this equation, sorry, with fractions, and we've rewritten it. This is an equivalent, because we could multiply by other common denominators. So this is one equivalent equation without fractions right there. Now, I've shown over here to the side how we would do that, but usually what I do, and it's an advantage, I think a little bit of a shortcut, The 6 is on the numerator when we're multiplying all these fractions. So you could just think of this as 6 divided by 3 is 2. 2 times 1 is 2. 2 times x is 2x. 6 divided by 2 is 3. 3 times 1 is 3. And 6 divided by 6 is 1. 1 times 13 is 13. So I've shown over here at the side, sort of the longhand version of how we get and why we get these numbers. But I think it's an advantage to just think of the division here and then multiply by whatever is left on the numerator. That's what I'm going to do for the balance of this lesson. So you might be asking yourself, well, why are we clearing fractions? What's the big deal here? Suppose we want to solve for x, because that's actually one of the main reasons why we clear fractions. We're trying to solve for a variable. So if we look at this option 1 and kept the fractions, there's the original. Normally what we would do is isolate the variable term right here. So we'd have to subtract 1/2 from both sides. Then we'd have to take the 1/2 and express it with a common denominator in order to simplify. And then up here, we're dividing by a fraction. So dividing by 1/3, it's the same as multiplying by 3/1. And we get our answer is 5. So that's option 1. The value of x is 5. Option 2, let's take the equivalent equation without the fractions. What do? Subtract 3 from both sides, divide both sides by 2. Boom. X is still equal to 5. Which option do you prefer? You said option 2. That's the option I prefer. I think this is much more straightforward once we cleared the fractions. So generally speaking, clearing fractions will make it easier to apply algebraic techniques. Sometimes we will want to isolate a variable in an equation, or sometimes we will want to solve an equation, find a value for that variable. So to clear a fraction, check the numbers or expressions in the denominator of all of the terms, determine the least common denominator, and then multiply each term in the equation by the least common denominator. So we've talked about what it is, why we do it. Now let's try a few examples. So we're given this equation, asked to clear the fractions. So we've got 4 terms here, 2 on each side of the equal sign. So on the left, there's -2 and 2/5 times x. And on the right side, we have x divided by 4 and -1/2. So zero in or focus in on the denominators. We've got 5, 4, and 2. So we're looking for the smallest number that 5, 4, and 2 all divide evenly into. So go to the biggest number, 5. Does 4 or 2 divide into 5? No. So let's double 5, get a multiple of 5, go to 10. Well, 2 divides into 10, but 4 doesn't. Then go to 15. Nope. Then go to 20. Oh, yeah, okay. 5, 4, and 2 all divide into 20. So there's our least common denominator. So now we'll multiply the 20 by each of the terms. So I've got the arrows going to each term in the expression. I put brackets around the complete equation, and I'm multiplying by 20. So 20 times -2 straight off the bat is -40. So here's where I'm going to go. 20 divided by 5 is 4. Now multiply 4 times 2 to get 8. 8 times x is 8x. 20 divided by 4 is 5. 5 times x, 5x. 20 divided by 2 is 10. 1 times 10 is 10. So it's -10 there. So there's the equation without fractions, the equivalent equation. What if there's a letter in the denominator? The thought process is still the same. We're looking for some common denominator, some common expression that each of the parts in the denominator will divide evenly into. So when we do the multiplication, that denominator portion will no longer be there. We're clearing the fraction. So here we've got three terms. We've got a 12 divided by x is one term. And we've got a 3/4 x and a negative 5/2. So three terms, one on the left, two on the right. Look at the denominators, x, 4, and 2. So we need, in this case, an expression, because we've got a letter. Now it becomes an expression that each of these denominators will divide evenly into. Dealing first with the integers, 4 and 2, the least common denominator of 4 and 2 is 4. In order for the x term in the denominator to be removed, the term that we're going to be multiplying every term by needs to be multiplied by an expression that contains an x. So take that x that we need and multiply it by 4. So our least common denominator here is 4x. It's the smallest expression that x, 4, and 2 will divide evenly into. Bracket the equation, put the 4x in the front, show the arrows to each of the three terms. So x divided by x is 1, so it will cancel out. 1 times 4 times 12 is 48, right there. 4 divided by 4 is 1, so those divide out. Then we're left with x times 3 times x. Okay, now that's all on the numerator portion, x times 3 times x, 3x squared. 4 divided by 2 is 2. And then we have 2 times the x that was here times the 5, 10x. And because there's a minus sign there, that's minus 10x. So we've cleared the fraction. We now have a quadratic equation. That's no problem, because quite often solving quadratic equations, we might have fractions, and then we need to clear it, and then we would set this equal to 0 and solve from there, if we were trying to solve. But for now, we're just talking about clearing the fraction. Let's look at another example. So to clear the fraction, remember, our goal is to find an expression that each denominator will divide evenly into. Now, with only one integer here, we know that 16 must be part of the least common denominator. Now we're dealing with the letters. So we've got an x squared and an x as denominators in two different terms. And when we have the same letter, so we have x in two different terms, we need to include the term with the highest exponent so that it will eventually divide out. Because x squared divides into x squared, and x will divide into x squared. If we just had an x, we wouldn't remove the x, all the x's in the denominator. We need at least the highest number on the exponent. So we're going to multiply each term here by 16x squared. There's the equation. 16x squared, multiply all the way through. So the x squareds right here will divide out, because remember, this is on the numerator, this is on the denominator as we're multiplying these two terms. So the x squareds will divide out, and we're left with 16 times 9, which is 144. X squared divided by x. So we'll take 1x out of the numerator and the denominator. We'll be left with 1x in the numerator. 16 times 15 times x, which is 240x. 16 divided by 16 is 1. So 1 times x squared times 51 is 51x squared. And we got the minus sign. Summary. I'm giving a question here and asking you to complete this one. I would suggest you maybe pause so you can check the answer in the next slide. But if we were given this equation and asked to clear the fractions, in summary, determine the number of terms. So here we got three terms, a -1 on the left side of the equal sign, x over 4 and negative x plus 10 over 6. It's two terms on the right. Next, focus on the denominators. There's no letters, that's fine. So it won't be an expression, it'll be a number. So in this case, we're looking for the smallest number. 4 and 6 divide evenly in 2. Because when we multiply that number that we're finding, that least common denominator, by the term, multiplied by each term, the denominators will therefore no longer be in existence because it will divide into the least common denominator. So we'll determine it, multiply each term by the least common denominator. So once you pause, you can write it down. I would suggest you write it down. Just do a check here. See if you know how to clear this fraction. If you said 12 was the least common denominator, great. We pop the 12 in the front. 12 times negative 1 is negative 12. 12 divided by 4 is 3. 3 times by whatever left in the numerator, which is x. 3 times x is 3x. Just have to be a little careful with this minus subtraction sign here, but if we keep the subtraction sign, 12 divided by 6 is 2. And then in brackets times x plus 10. We would then have to carry on with our algebraic skills if we were, say, for example, solving for x. But this skill, clearing a fraction, just make sure that you're comfortable, confident, know what it is and why we do it. Till next time, have yourself a great day.